Alright, another experiment on induction motor is called the lock rotor test. So it's similar to short circuit test in transformer. Now in transformer, when we short circuit the secondary, we're actually drawing out the maximum current, right? Whereas in the lock rotor test, we actually lock the rotor. In other words, we hold onto the motor, the rotor, we do not want it to move, and yet it's still trying to move, isn't it? So it therefore has to draw out a lot of current. In the lab, we actually use a magnetic field to hold on to the rotor. That's what it means by lock. It means we lock it and it doesn't allow it to move. Now the equivalent circuit of the lock rotor test is a series circuit, just like the transformer, where this is RE1 and XE1. Now if you do recall, RE1 is an equivalent, that means it's a combination of primary and secondary. Right? Remember we said induction motor we model after transformer, so we have stator as the primary circuit and rotor as the secondary circuit. So we lump the R1 and R2 together, call it RE1. We lump X1 and X2 together to call XE1. Alright? Alright, so the job here, right? In the lock rotor test, you measure the power, the lock rotor power. And remember, it's a three-phase power. You measure the lock rotor voltage. Again, this is the line voltage that you measured. And the lock rotor current, which is the line current. Now, because it is a star-connected circuit, then what is the phase voltage then? Therefore, it's divided by square root 3. How about the line current? The phase current is the same as the line current. Same. Star-connected circuit. Okay, so based on this, the method will go straight away say that the lock rotor power is three-phase power. So it's square root 3 BL IL cosine theta. Right? Okay, and the lock rotor power is 3 times I square R. 3 times I square R. The true power is here, isn't it? And it's three-phase, so therefore I square R times 3. Now, which I, of course, is a phase current, which is the same as line current actually. Yeah? So I have here and I have here. Can I find this? Yes. RE1 can be found. Right? The next is to find the impedance. Impedance per phase, so you use voltage per phase. Phase voltage divided by phase current. Phase current. Of course, here is the line voltage divided by square root 3. Here is the same as line current, star connected. So I have these two reading, my impedance R. Impedance triangle say, if you know R, you know Z, can you find X? Yes, the answer is you can find X by using Pythagoras theorem. Okay, and that is the lock rotor test. Okay, again, it's a method. If you want to really master this small topic, remember that the power is a three-phase power, so it must be 3 times I squared. Alright, unlike the transformer single phase, so we say power is just equal to I squared R. Okay, and then use Pythagoras theorem to get the answers. So that is the lock rotor test and the no load test. Right? Maybe you can just go through one simple example to illustrate these two experiments. Okay, if I go and look at the tutorial questions. Alright, no load test and lock rotor test. Alright, tutorial 9, question 1. Alright, it says it's a 415 volt 3-phase induction motor, 50 Hz, and you have a no load test data. B and L is equal to 415 volt, I and L is equal to 7 ampere, power factor equal to 0.15 lagging. Right? And the rotational loss is equal to 200 watt. Okay? Alright, and then you are also given the short circuit test data. But before we do that, let's look at this. So then the question asks you to find Find RC and XM. Find RC and XM. Remember that was the parallel circuit. Okay? Alright, how to do this question? Alright, remember we started off by saying that okay, the power that I measured is equal, you are not given, right? In this question here we are not given the power. So we actually have to calculate it ourselves. Yeah? The three-phase power is equal to square root 3 VL IL cosine theta. So VL is 415, IL is 7, cosine theta is 0.15. Right, so I found it. Okay? Now after I have found my no load power, I already know the value. Then I say this is a three-phase power that consists of three power if you recall. What are the three power? The core loss power, the stator loss power, and the rotational loss power. Right? I forgot to give you one more information. You are told that Rs is equal to 1 ohm. Okay. Core loss power is V squared on R, but it's three-phase, so you must multiply by 3, right? 3 VPH squared divided by RC. Series circuit, 3 times I squared RS. Okay, and rotational loss. Okay, alright, ask ourselves, do we know all the values? Yes, this one is I already calculated just now. VPH, what's VPH? VPH is 415 divided by square root 3. Okay, this one is an unknown. Alright, VPH I know, it's 415 divided by square root 3. Okay, now how about my IPH? Do I know IPH? Yes, 7. Because phase current and line current is the same. RS is given. Rotational loss is given. So in this equation here, I only have one unknown RC. So RC can be found. Right? So therefore, RC can be found. Right? Right. Then after that, how do I use Pythagoras theorem to get XM? Is to find IC. IC is equal to VPH divided by RC. Right? I know RC. Do I know VPH? Of course. VPH is the 415 divided by square root 3. Right? Then how do I find IM? IM is equal to Pythagoras theorem, INL phase square minus IC square. Right? What's my INL? It's 7. It's 7. 7. Okay? IC I found just now, right? So IM is found. Once you know IM, then go and find XM. XM is phase voltage divided by IM. IM already got it. VPH is the 415 divided by square root 3. Right? So XM can be found. Right? So this example illustrates to you the no load test. Okay? Now the part B of the question 1 is the short circuit test or the lock rotor test. Alright, so the short circuit test, or in other words, lock rotor test. Alright, so we illustrate. So the data given to you is the voltage measured, the line voltage is 200 volts, the lock rotor voltage. The lock rotor current is 38 ampere, and power factor is equal to 0.35 lagging. Okay, so you are asked to find, so the value is to find RE1 and XE1. Okay, so we need to know what is the lock rotor power. It's a three-phase power, right? And I'm not given, so I have to use my basic formula like ECAM, which is equal to square root 3 VLR ILR cosine theta. Right, the line voltage. What's my line voltage? It's 200 volts, so 200, and my current is 38. cosine theta is 0.35. So I know my log rotor power already. The total power in this experiment. Then I start my method by saying that my log rotor power is actually 3 times I square R. Right? Which I, of course, is the phase current. So I know this value. That's equal to 3 times 38 squared. No need to divide by square root 3 because it's a star connected circuit. Then multiply RE1. One unknown, so RE1 can be found. Right? After RE1 is found, then go and find XE1 by using Pythagoras theorem of the impedance. Okay, so impedance is equal to VPH, one impedance, there's 3 phase, right? So phase impedance is VPH over IPH. So my VPH is equal to 200 divided by square root 3, my IPH is 38. So I got my impedance, I got my resistance. How do I find my reactance? Pythagoras theorem. Okay, so it's a method. Practice it a few times, then you should be able to remember the method. The tricky part is that remember the total power is the 3-phase power, so it's 3 times I square R. Whereas for transformer, it's just I square R because transformer topic was single phase transformer. Okay, that's all. Thank you.